Hi, Casey Cobb here, and today we're going to be talking about using AI to break down complex tasks and perform calculations for you, as well as some of the issues that you might run into when you're doing this, just based on the technology itself. And this was based on an experience I recently had talking with a scientist who was doing this very thing, and he encountered some issues, and I thought it might be good to share this with others who are trying to do something similar. So first things first, choosing your provider and model. There are a lot of different options out there. ChatGPT from OpenAI, Claude from Anthropic, Gemini from Google. There are other models as well. A lot of people are going to be familiar with ChatGPT. That's totally fine. Pick which one works best for you. I personally recently, for a lot of challenges, I find that Claude from Anthropic is oftentimes, a lot more helpful, but your experience and mileage may vary. So find what works best for you. You might even do it with multiple models and compare the results. So the first piece here, though, is that you're going to want to compare the difference between base models and reasoning models and know which one to choose. So in general, a reasoning model is probably going to be your best bet. And I just wanted to go over what the difference is. So a base model, at least right now at the time of recording, something like ChatGPT just released GPT-5. Previously, 4.0 was a simple base model, and that's still one of the underlying models behind GPT-5. But it's just it's a token prediction machine. So like on your phone, when you're typing a text message and there's another word that it's saying, you can just kind of autocomplete word after word after word. That's a really simple version of what these LLM technologies are doing. They're going through and just based on all the previous words that they've generated and all the words that you asked it, it's saying what's the most likely next word. Now they're using tokens, not words, but we'll just treat them like they're the same right now. So it's just going to go through and do that for every single word. And that's based on all its training data that the model has. So in many instances, that might be great for talking through something or trying to understand something. But when you get into a complex calculation or trying to figure something out that requires making assertions and conclusions based on those assertions, you're going to be better served using what's called a reasoning model. With GPT-5, at least, you can choose between thinking, I think extended thinking, and they have a couple different options of thinking, and that's going to be their reasoning model. You can also put in extended thinking for Anthropic. All these providers have a similar feature. And what that's going to do is behind the scenes, when you ask it a question, the LLM is going to generate assertions that you're not going to know. You can actually sometimes see its thinking process, but then based on those assertions that it generates, it's going to conclude something and share that conclusion with you. So that is oftentimes going to be your best bet when you're trying to do a complex calculation, because it's just going to be doing some of that pre-chewing or that pre-thought for you. It's also less likely to hallucinate. So LLM technology is just kind of baked into it. It can just make stuff up as it's generating words. It's really kind of scary. So if you use a reasoning model, it's going to cut down on that hallucination. In general, as new models have come out, they've gotten better at not hallucinating, but it can still happen. So reasoning models on their own, just like base models, they're not grounded in search results or ground truth unless they actually go out and do a search, which many of them can. Sometimes automatic, but sometimes you have to set that you want it to go search. That's going to be less likely to hallucinate, but you're going to be better served choosing a reasoning model. So if you have that option, pick that. So next, the initial prompt. This is really important because you're going to set the foundations for the kind of series of things that are going to happen after you ask it a question. So you want to set it up for success from the very start, and that's going to begin with the prompt. Reasoning models, or really any AI model, if you give it the context of what it should be responding as, it will respond better for your particular prompt. So you should tell it, say, you are an expert in field XYZ. Give it as much detail about its expertise as you can, as you know. You might even use a prompt to say, generate a prompt, an initial prompt as an expert, right? So you're using the prompt to generate the prompt, and then you take that prompt that is really well thought out, as all the qualifications and expertise and education that you're telling the LLM to respond as. And then that's what you're going to use to generate the next step. So get that expert prompt. And I'm going to show you an example here in a minute. And then think about what you're trying to conclude. Now, the example that kind of prompted this video was that a scientist was trying to calculate how much of a certain material was in industrial items. I won't say the specific here, but if you just ask the AI to tell you how much, it's going to give you an answer, but that may not actually be correct. So the first step here to avoid the hallucination problem is to ask the LLM to generalize the problem. So one example that I did in preparation for this video is I had it tell me all the rare earths in smartphones. And then I picked one of those rare earths, so neodymium, and I asked it to generalize the problem into a series of steps that I could then go through and construct my query and my calculation. So I asked it to generalize all the different, what are the types of smartphones? And it came up with, frontier models, mid-range phones, and then really basic phones. So if I was going to ask it to estimate on neodymium and smartphones, I would want to be specific about what kind of phone I'm asking for. And then for all three of those categories, compile the data from that into what my conclusion is. Because if I ask it to tell me across all phones, none of that number is not going to be accurate. It might be accurate on average, but it's not accurate in the specifics, and that could be problematic. So here's an example prompt. You could probably make a much better one. This is just something that I came up with to start. So you are a telecom and industrial design expert engineer for industrial rare earths in phones. Perform a comprehensive analysis on the amount of neodymium in 2025 flagship phones, for example, iPhone Pro, Galaxy S Ultra, Pixel Pro, in the following components. And so I would, in my previous prompt, as I was brainstorming, I created a list of categories of phones and then categories where neodymium is present. And so I would list those categories here. And then this is really important. So I say, don't give me a single number. Rather, I want you to display the raw data for each component that you find data for. If you cannot find specific data, then tell me you couldn't find it. Do not estimate a value. And it's going to understand the asterisks here are kind of emphasizing it. I will look at your results for each element and create my own final value based on what you present. So I'm being very specific to the LLM here that I don't want it to give me an answer. I want it to give me the inputs, and I will calculate the final answer. So from that, there's another piece that you may or may not be aware of, and it's called deep research, at least for ChatGPT. That may actually be a trademark term for OpenAI. But all these models have the ability to do extended research, extended thinking on a particular topic. So once you have the inputs clear that you're looking for, you can use deep research to compile the values based on the research that it does. So I can actually say, okay, I've abstracted out my problem. I know the different types of smartphones. I know the different elements that this rare earth is in. And then I want it to do a deep research for how much rare earth neodymium is in a particular type of phone and a particular element. I could be specific, do a deep research query for each particular component rather than telling it to do a much broader search and compile all the data. You might have good results with actually asking it to, do the whole thing. But the more specific and granular you can be, it's going to be a little bit more work to compile that at the end into your final calculation, but the more you're going to be able to trust the data. When you do a deep research query, it's going to ask you to answer a couple questions that it might have that will help it with its research. You may want to note the answers that you gave it for your final report so that you can have some caveats or, details about what went into the research. And then once it comes back with the results, it may be a pretty substantial amount of text. You can then ask it to take those results and put it into a table that's easier for you to parse. You do want to double check that the data in the table matches what was in the deep research. So as you go through it, go check the citations, check the sources, check where it got the data that it compiled, because that could be another source of hallucination. But once you have that final table, you verified it all, now you have the inputs for the formula that you're going to apply and calculate. So there are a couple gotchas to keep in mind. It's very tempting to trust LLMs at face value because they seem like you're having a conversation with a person that just seems to know everything. But LLM technology tends to be confidently incorrect. It can be confidently incorrect. But when you're grounding it in search, you're grounding it with deep research, with actual data, it's less likely to be confidently incorrect. But you can go check all the actual results and compile that into your final calculation. And doing that process, remaining skeptical, trusting but verifying, you're going to reduce the likelihood that anything is wrong. And if you do find something's wrong, you can confront the LLM and ask it to do more research and then be more critical of the final results. It'll easily admit when it did something wrong. It's very open to saying that it did something wrong. But just keep in mind that hallucinations are fundamental to the technology, at least right now. To some degree, they're getting better and better at eliminating or reducing these hallucinations, but it's always going to be a component because it's just kind of baked right into the LLM technology. Also, as I mentioned, double check the sources. Now, LLM results have links that they show where they got the source. One note, I actually learned that scientist that was telling me about the problems he was facing with this, when he checked the sources, the source was a whole report about how the data that was reported were all incorrect. So that was the very essence of the report. But what the LLM had done is just taken those values and put them into the calculations. So it was actually taking data that the report said explicitly was wrong and using that as though it were correct data. And so you're going to find things like that because the AI is not evaluating each source comprehensively. It's taking those numbers once it thinks that it's right, and it could be wrong. So always want to be mindful of that. And then if what you're searching for doesn't have a lot of data or a lot of reports or a lot of research on it, you have to be really careful because it's going to potentially create data around a very small number of data sources or just an estimate or just an inference from something that it found on the web. And that may not be correct. So you'll notice in my prompt before I said, if you don't find the data, just say you couldn't find it. It may or may not respect that request. But if you know from the start that there's not a lot on Google when you search for this particular problem or details around that problem, you need to be really mindful of the results that you get from the LLM. And you may need to back out and abstract your problem and then kind of based on assumptions that you explicitly pick and specify, then recreate your approach to the solution with those inputs and solve it as best you can. But if you ask an LLM to give you an answer, it's going to give you an answer, but again, it might not be correct. So these are just a few high-level, things to keep in mind as you're using AI to create calculations and, answers that you may need for, various purposes in your research. And if you follow these guidelines, you're going to get a much better result. Take the inputs and then use that to calculate the final output. Just don't trust the AI to generate that completely. You might also find that you take the inputs and you ask it to calculate it, and then you calculate it and see if the answers are different. And if you do that enough, then you might kind of get a sense of where it's good and where it's not so good. And then you can be mindful of that for the future. It is a moving target because as new models come out, they get better and better at this stuff. So it's not always set in stone forever. But using these rough guidelines, you can definitely get a lot more done from an AI than doing it all yourself. But you just have to take the good with the bad. So I hope this was helpful. And feel free to like and subscribe to this channel if you want more updates like this that might help you in the future. And I look forward to bringing more videos like this to you in the future.